Hello, this is Paul from Fast Tech. In this lecture, we're going to deal with the important limit. Is the fraction, the limit of a fraction. We have a different type of fraction. The major one we call it is indeterminate form. The fraction is called the indeterminate form. Indeterminate is not easy to determine, to decide. Give you example, and later we have 1, 2, 3 type of fractions. Okay, I give you example what is indeterminate. So can we see? The first type we call the 0 over 0. What does this mean? Of course, we put here. What does 0 over 0? For example, so how do you think of the limit? X plus 0 if over here is 2x over 3x. Okay, what the limit? The first limit, you know, this is a polynomial, so direct substitute approach 0. This is approach 0, right? So can you see the numerator is 0, denominator is also approach 0 if we use the quotient rule. So can we say therefore the limit does not exist? No, we know the limit exists. So what is the limit? Can you see this? We can divide it by x. Okay, divided out x. Why? Because when we're talking about the limits, x does not equal 0. Remember this, the limit. We exclude the x at 0. That's all we're talking about, the limit. Okay, what the limit of function as x plus 0 means what? Means what is the function approach 2 as x approach 0. Okay, does not equal to 0, which means just the neighbor of 0, which means x does not equal 0. In this case, if x does not equal 0, we can divide it out, x. After we divide it out, what do we get? Of course, we get 2 out of 3, 2 over 3. Okay, a constant number, the limit of constant number is 2 over 3. Okay, and then another example, can you see? X plus 0, here is 5 over x, 3 over x. Okay, is this what? This is also 0 over 0, 0 over 0. If we divide it out x, and the result we get is 3 over 5 over 3. Both of them are 0 over 0 form. However, the limits are different. So this is why we call the indeterminate. Okay, 0 over 0 could be any number based on what is your fraction. Okay, can we see? And later I will give you another example. And all these kind of we call the indeterminate. Okay, so the first is a fraction. Rational functions we just say irrational, and the irrational fractions we're going to see we have to rationalize. Okay, later. And another is if we deal with multiple fractions. How do you deal with the multiple fractions? So we need to combine the fractions together. Okay, I have a 1, 2, 3 example. Each one we're going to do a rational function first. This is one rational function, right? Okay, so how do you do? And the first we have to look at is this indeterminate? Is this indeterminate? All we need is quotient. If you use the quotient law, okay, to take a limit to the numerator, so x plus -3 per log, directly substitute -3 square and minus 9, and finally we get what? You get a 0. Okay, if you take a limit to the numerator, you get a 0. The same, you're going to verify. If you put the limit to the denominator, you also get a 0. What does it mean? Means what? Means this is an indeterminate form, 0 over 0. Okay, we usually wrote in this, and this is a indeterminate. This is an indeterminate form, and we simply wrote in this 0 over 0. You understand? Take a limit to the numerator, goes to 0. Take a limit to the denominator, goes to 0. So what do we do? Is similar as the first. Okay, and we need to divide it out, or we're going to simplify this fraction. This is rational. How to simplify? All we need to do is factor, okay, the numerator. So now the basic factor, and then we probably find a common factor to divide it out. Okay, so all we need to do here is to factor the numerator, factor the denominator. After we factor, see what do we get. We're going to factor. Okay, the first is x is a common factor. We factor out x, right? Okay, so x plus 3, no problem. The denominator, this is a quadratic expression. Okay, quadratic is how to factor the quadratic. All we need to do is factor this. This is 1, 1. This is 3. So after you factor, we should find the two factors of this quadratic form, which is the first is x minus 4. The second is x plus 3. You see, 3 times negative 4 goes to negative 12. 1 times 1 goes to 1. And the middle term is negative 4x plus 3x goes to negative 1x. That's 2. Okay, you finish the first step. Now what to do? We need to divide it out. Do you remember when x approach negative 3, which means x does not equal to negative 3. Therefore, we know x plus 3 does not equal 0. Does not equal 0 means a number. So on each function, so we can divide it out. Okay, so we're going to divide it out now. Okay, so all you need to do is what? Is just divide it out. Okay. So we say divide out x plus 3 because they are not 0. Okay, divide it out. See what do we get? Okay, what do I get? I get this. I get a limit x approach negative 3. Now, much easier. Only x left on the top. Only x minus 4 left on the bottom. Now what to do? We can directly substitute, right? This is what? This is a rational function. We can do directly substitute. All you say is the quotient law. The limits take the limit to the top, take the limits to the bottom. Okay, all is direct substitute. Okay, we use direct substitute. Substitute the x by negative 3. So what do we get? We will get this. Okay, negative 3 per here, right? Negative 3 per here. Negative 4 is there. Of course, you do calculation. Negative gets positive, so that 3 out of 7. Okay, this is the result. Okay. And for these type of questions, the first step is the most important, right? We need to factor, and then divide it by the common, divide out the common factor. Look at one more. This is the second type. The second type is to what? To deal with the irrational. Okay, and this is a fraction, and this fraction we have irrational, a radical there. So now first, okay, look at it. Is this an indeterminate form? If we directly substitute that, the numerator goes to 4a93 minus 3 0. The bottom also go to 0. Okay, means if I directly look at it, the indeterminate, right, is 0 over 0 form. Okay, so we cannot, but we cannot divide it out of something. What to do? Rationalize. Okay, if we see this, all we need to do is rationalize. Of course, it's a rationalized numerator, so we do this. Rationalize. Of course, rationalize the numerator. So how do you do? Is times the conjugated, right? So all we need to do is times conjugated. Let me see, rewrite. Okay, so here should be, I'll put this again, u part 2. This is u, not x, so you have to use u. Okay. I wrote a little bit longer. Okay. And the first 4u plus 1 minus 3. And u minus 2. This is the original. What do we do? Times the conjugator. Times the conjugator of the numerator. If someone remember, the conjugator is what? Here is a plus 3, right? This is the conjugator. Okay, that's the conjugator. So you times the number to the numerator times the same number to the denominator. 4u plus 1 plus 3. See, and this we call the rationalize. Okay, why this is rationalize the numerator? Because now we have we can simplify all this, or we can simplify the numerator. How do you simplify the numerator? So can we see? So let me go into simplify to simplify the numerator. After simplify the numerator, you get a very simple. What is that? The numerator is equal to a minus 3. If I say this is a, this is a, this is a plus 3. The difference times the sum, remember, is the difference of squares, right? This is a square minus 3 square. What is a? Our a is the square root of 4u plus 1. This is a square minus 9. What do we get? So can you see? We will get this square is 4u plus 1 minus 9. We will get 4u minus 8. So we get a very, very easy one. Okay. Of course, we can do one more steps. 4 we factor 4 out with u minus 2. I will use this to the numerator. This is the simplified. After the simplify, we get the numerator is very simple. Do we get it? I will put here. Okay, so is this, that's the limit u approach 2. Let me see. We get a 4 times u minus 2. Okay, how about the denominator? Denominator I copy is u minus 2, and here is times the square root 4u plus 1 plus 3. Someone said we still have a square root, but don't worry. Okay, why? Because later this does not goes to 0, so it's okay, we can directly substitute. So now what to do? Okay, simplify again, right? Divide it out. We can divide it out. Let's divide it out. See, divide it out, there's a comma. Okay, u minus 2 does not equal 0, right? So we can cut, divide it out the comma factor. So we simply say is divide out u minus 2. After divided out, so we have this. We get a simple one. U approach 2. Okay, so now the numerator is 4. The denominator goes to this square root of 4 u plus 1 plus 3. We're going to the irrational. This radical goes to the denominator. So this time it will not make a trouble for us. Why? If we're going to directly substitute it, so can you see u is 2, 4u is a plus 1 is 9, square root of 9 is 3. What do we get? Okay, 3 plus 3 is 6, is not a 0. Okay, so we don't have any trouble. The last one is directly substituted. Or someone says is the quotient rule and then the root rule, right? Okay, or directly substituted. You use laws, or simply say we use laws. After we use laws, what do we get? So we will get this. There's we don't have a limit, right? So we already cut. We don't have a limit. The numerator is 4. The denominator, so can you see, is 4 times 2 plus 1 and plus 3. This we call the directly substitute, and then you do calculation. See what do we get? We get a 4 over 6, right? We just do calculation. Simplify is 2 over 3. Okay, so this is the result. And then one more. Okay, so this is the type if we have irrational. So rationalize. No matter is the irrational part is on the numerator or the denominator, it's just a rational. Okay, rational one part. So one more. Can we look at these questions? Okay, so this time is still. I was going to show you these questions. It's still indeterminate, but this time the indeterminate is strange. Okay, is what? is infinity minus infinity. So someone said, why is it infinity? If we directly use the difference law, okay, 1 over 0, of course it goes up into infinity. This also goes to 0. 1 over 0 goes to infinity. You say infinity minus infinity. Okay, so how to deal with this type? I give an example. This is the indeterminate. Okay, and this type of form could be equal to any number. For example, if this is n plus 1, if n goes to infinity, how do you think? This is the equal to infinity, right? Infinity minus n. Infinity minus infinity, do you know what is the result? It's 1. See, infinity, this is goes to infinity. If n goes to infinity, this goes to infinity. So, but do the subtraction, we get a 1. Another, if it's plus 10 minus, see, this is the infinity, goes to infinity, and this also goes to infinity. However, the difference is always goes 10. See, the same type, but the results are different. Could be any number. Okay, depends on your questions. So now we're going to deal with this. What do you do? We have a basic rule. Okay, this fraction, we combine the fractions. Okay, the basic method is this. We just combine fractions. You know how to put the two fractions together, right? Okay, is find the common denominator and then put them together. So first, what the common denominator? We need to factor this denominator. Are we going to factor? Let's see. The limit. The first is there. I will put this is t is a common factor. We factored out, and then t plus 1. Okay, the first step is easy. It's just a factor, right? So the first is a factor. The second is merge them together. So compound fraction. Now you know how to compound fraction. Okay, find the common denominator, which is this one, right? T times t plus 1 is a common denominator. That's the least. Whatever we merge these two together, see what do I get. Okay, that the limit t approaches 0. Okay, so we merge the fraction into one fraction. T times, okay, this is the LCD, right? So the least common denominator, or the common denominator, we put t and the t plus 1. Okay, this is the denominator. So this we have the times t plus 1, right? So here is t plus 1 minus 1. What do we get? You get it t here only. Okay, and then what to do? Divide it out, right? So now is just divide out the common factor t, right? T and the t. T does not equal 0. Okay, so you can cut. So what do we have? We have this simple list now. Okay, t approaches 0. Here is 1 left. Here's 1 times this is t plus 1. This is a rational, right? Directly substitute. Directly substitute now. Okay, with direct substitute. So t goes to 0, that's 0. See, what do we get? We will get this 1 over 0 plus 1, which is 1. That's the result. Okay, that's the 3 types of fractions. So usually we will meet. Thank you. That's all.